We're going to discuss liquid-liquid extraction as our next separation technique. Two very closely related techniques that are often confused are extraction and washing. So I'm going to try to differentiate between these two ideas. So say that you have a mixture of three components like the one shown here, and you would like to keep the yellow squares and get rid of the red and blue components. We would say that washing is getting rid of the stuff that you don't want while allowing the stuff that you do want to stay behind. So everybody should be kind of familiar with something like the picture on the right. You're washing off lettuce or some vegetable in the sink, and you're keeping obviously the lettuce behind, but you're washing off all of the dirt and other things that you're trying to get rid of. An example of this that you've already done in the lab is a filtration where you have been able to keep the material that you want up in the funnel that you're using and wash through dissolved materials that you would like to get rid of. This is different than an extraction because if we were to perform an extraction on this same mixture, we would be selectively pulling out this material, this yellow component that we did want, and getting rid of the materials that we did not want. Hopefully you can tell the difference here between this process and a washing. In the washing, you're actually just getting rid of the stuff that you did not want. Here, you're actually pulling out the stuff that you do want. And so an example of an extraction that many of you should be familiar with is making coffee. So if you think about all of the components that are in coffee beans and coffee grinds, we have lots of different stuff here. Really importantly, this one right here, right? Okay. If we treat this with hot water, and so we brew the coffee, we are extracting, we are pulling out the components that we want to drink in our coffee, and then the other stuff is being left behind in the grinds on the filter. You can sort of liken this to the hot filtration that you may have had to do in the first experiment. So if you had an insoluble solid impurity floating around in your solution, you may have had to filter that using a stemless funnel. And so you were able to keep the stuff that you didn't want behind and pull through the material that you did want. The idea of a liquid-liquid extraction is that you take a solution, so for example the one shown here, where you have a certain solvent interacting with all components in the solution, but then you expose this solution to a new solvent and you are able to selectively pull out the desired components into the new solvent and leave the other components behind in the original solvent. To perform this technique in the lab, you will use what's called a separatory funnel. And I know this might not be the picture you had in your head when you hear a separatory funnel, but that's what it's called. And actually, the unfortunate thing is the only picture that I can get a hold of here shows this in the open position. And I do want to emphasize that for many of these steps, the funnel needs to be in the closed position. And so something that your TA will constantly remind you of is to don't forget when that needs to be closed and when that needs to be open. I will just keep this note up here during my presentation. But the first thing that you're going to do is to take the solution with all of the components in this mixture that you have dissolved and pour it into the separatory funnel. The next step is then to add the second solvent that you want to expose all of these components to. And the idea is that you are hoping that, in this case, the yellow components interact better with the pink solvent that's being introduced here than they do with the green solvent, and so they're going to favorably want to go into the pink solvent. And the only way that this process is going to work is if the two solvents, so the pink and the green in this case, are not miscible, meaning they need to form two layers in the separatory funnel. So it's very important that when you look at the interface of these two liquids that you're able to tell where one layer stops and the other one starts. Now with the stopcock in the closed position still, you're going to fit the top of the separatory funnel with a stopper. And it's going to actually look something like this in real life. And this is a ring clamp, notice here, that you will use for this process. The first step, though, is to actually take the separatory funnel and invert it, making sure that you keep a close grip on this stopper here so that you don't end up with a mess on your hands, literally. And you're going to swirl the contents of the sep funnel because you want to expose everything in there to both of the solvents that are present. A key thing, though, is to remember to vent periodically during this process by opening up the stopcock, because you're very likely to have some gases evolve during this process, and so some pressure build up, and you need to relieve that. And you're going to repeat the swirling and venting probably 4 or 5 times. If gas is still evolving, you want to keep doing it until that stops. Initially, when you flip the sep funnel back over and put it in the ring clamp, everything's going to be all mixed up, but after a very short amount of time, you're going to see the two layers start to separate back out, and usually there's some bubbles of gas trapped in there, and so you might see something like this. And in that middle layer, you have everything, all of the components that were in your mixture. But as everything starts to separate out, if you chose your solvent correctly, the component that you would like to isolate should go into the solvent that you just exposed it to, so the pink solvent. And the stuff that you want to get rid of should stay behind in the original solvent that it was in, so the green solvent. So if everything worked perfectly well, the stuff that you wanted, that you were interested in, you were able to pull out of the green solution and get it into the pink solution, and you were able to leave behind all of the stuff that you didn't want. You can then open up the stopcock here and drain that lower layer into a flask. You're going to close the stopcock back off as soon as all of the green has drained out, and that will leave in the separatory funnel the stuff you're interested in dissolved in the pink solvent. Then you can pour the contents into another container through the top of the separatory funnel. At the end of this process, then you should have 2 flasks, one that contains the desired component and one that has all of the stuff in it that you were trying to get rid of. Like anything else, though, this process is never 100% efficient, so you are still going to have some of the component that you are interested in floating around in that original solution. So then what you're going to have to do is what's called a re-extraction, meaning that you're going to need to take that solution B that still has some remnants of the component that we're interested in and treat it with some fresh solvent and repeat those inverting, swirling, venting steps again. And hopefully the second time around you're able to grab a hold of the remaining compound, and then you can drain off the lower layer again, and then finally pour that top layer here into, combine it with that original extract A. And hopefully now you've been able to recover all of the material that you're interested in. However, there are going to be times when this has to be repeated over and over again to be able to extract everything you want out of solution B and get it into solution A. So you can read Zubrick about the calculations that you can perform if you know the solubility difference between solvent A and solvent B. If you don't know the solubility difference, then a lot of times you're going to have to check for signs of your material in the solution B to see if it's still there or if you got it all out. Let's take a look then if we were doing a wash and see how that's different than an extraction. So this time let's assume that the mixture is dissolved in the pink solvent and that we're going to put all of that solvent into the closed separatory funnel. And then we are going to add to this solution the second solvent, this time we'll say the green solvent, to form these two layers in the separatory funnel. The next steps are going to look identical to an extraction. You're going to invert, swirl, vent, and then repeat. And just like before, when everything is allowed to settle back down and the layers are allowed to reform, you will start to see this separation. But this time the key difference is the component that you're interested in will stay in the original solvent, while the impurities or things that you want to get rid of will go into the new solvent. So the key difference between an extraction versus a wash is that in the extraction you're using the second solvent to pull what you want out, and with a wash you're using the second solvent to basically push anything that you don't want out of that solution. Let's talk a little bit about the identity of these solutions and the solvents. Obviously the less dense solution will go to the top of the SEP funnel and the more dense will go to the bottom. This primarily will be correlated to the density of the solvent that's being used. There is some dependence on the concentration of the solute. However, we will not be working with concentrations that will be high enough to impact the density for the most part. So most often the top layer is the organic layer, and that's simply because most organic solvents are less dense than water, and water happens to be the other layer most of the time. So common organic solvents that you will see used for this process are shown here. If you happen to be using a halogenated solvent, and most often for you that would either be chloroform or dichloromethane, in these cases these are actually more dense than the water, so they would be in the lower layer. Typically in an organic chemistry lab, extraction is going to be used when you have an aqueous solution and you're trying to pull an organic component into the organic solvent. And washing will be used when you have a solution in organic solvent and you would like to wash out the components that are water soluble.